piece a little bit, but we are going to continue to do a little bit more simplifying first. So, yesterday we started the process of simplifying rational expressions. A couple of key things that came out of that. First off, a rational expression, essentially a fancy fraction. Turn off whatever's on. Okay. Just a fancy fraction, and with that, one of the key things that I do want to emphasize on that piece is every single year I have people come to me and say, like, Benson, can I do this? And I always respond with, if it was just regular numbers, could you do it? For example, people are like, okay, I've got x plus 2 over x. Can I cross off the x's? Well, if it was a 1 plus 2 over, okay, 1's a bad idea. A 3 plus 2 over 1, could you cross that off and have it be the same? The original was 5/3. The new one is 2. Are 5/3 and 2 the same thing? No, you can't do it. So, what we do with regular fractions is what we do with rational expressions. Yesterday, we had started by working to simplify and find the excluded values. Now, as you go through and simplify and find excluded values, generally speaking, excluded values are not something I'm going to be asking you for every single time. I will on certain problems where it's just a straight, here's the single rational expression, simplify it down. But excluded values are going to be something that builds into a later part of the chapter. That's why we start finding them. But oftentimes when we simplify, it's just going to be simplify if it's doing more than just a single simplify. What the heck am I doing? That's not supposed to be there. Struggle bus. I looked at 2 different problems and that's not going to work well together. Okay, that's better. X squared y z to the 14th over 45 x squared y z to the 20th. Okay, if I am trying to simplify this down, Caleb, where do I start? Leaving you with? 1/3. You see what divides out of both 15 and 45? The answer here happens to be 15. That leaves you with a 1. That leaves you with a 3. So yes, 1/3. Brooklyn, where do we go next?
X.
Move on to the x's. What's happening with my x's?
They cancel out.
They're canceling out completely. X squared over x squared. They're gone, they're dead, they're not around. Okay? That's it. Now what?
The Y's cancel out.
The y's also disappear. Malia, how do we finish it off?
Do the Z.
And what am I left with the z's?
Z6 on the denominator.
Z to the 6th in the bottom, because 20 minus 14 is 6, and the bigger number was on bottom. Kasia, I've got 1 over 3z to the 6th. Is this the same as just 3z to the 6th? No. Far too often I come across problems like this, and the first thing people do is get rid of the 1. If the 1 is in the numerator, you cannot get rid of it. If the 1's in the denominator, can we?
Yeah.
Yes. Okay. Are we done with this problem, though? No. One other thing I needed to do. Quinn, how do I work to find excluded values?
You set the denominator equal to 0.
Which denominator?
The first one.
The original denominator, that first denominator. Now, yesterday we talked about the fact that when we set that denominator equal to 0, there's a couple different things that we can pop up. We didn't talk about that piece. I got ahead of myself. There's a couple different situations that can pop up. Sometimes there's going to be addition and subtraction in here. Sometimes there is not. If there's addition and subtraction in there, you're going to want to factor it. If there's not, you don't have to factor it, because everything's already being multiplied. And the thing that we did talk about yesterday is if a bunch of things are getting multiplied together and giving you 0, what's the only way it happens? One of them 0. Now I can go through and I can set 45 equal to 0, x squared equal to 0, y equal to 0, z to the 20th equal to 0. But in the end, what's that just going to give me? Zeros for x, y, and z. If you recognize that, go ahead and write them out. You don't have to write this piece out if you recognize that. My excluded values are x equal to 0, y equal to 0, z equal to 0. You do need to make sure that that's that original denominator that you're working with, though. Had you set the simplified one equal to 0, you would have gotten z equals 0 as one of your excluded values, which honestly is the most important of the excluded values because it shows up as excluded in both the original and the simplified form. And you probably noticed in the simplified form there's no y or x in the first place. But generally speaking, when we're talking about situations where we have different variables, just because the variable disappears doesn't mean it's not going to be still an important piece in a situation where you have like real life things going on. Can I come up with an example off the top of my head right now? No. But in short, you need all 3. That is a cubed. I know it's not the easiest to read because what my pen did. (16x cubed y squared over 64x squared minus 32x). Okay. Now there's addition and subtraction involved. If there is addition or subtraction in your fractions, you cannot cross anything off unless those addition or subtractions are all stuck in parentheses. In other words, it's fully factored. Can I factor the numerator? No. Monomials do not factor. The numerator is what it is. Can I factor the denominator? Yes. What kind of factoring are we doing? Greatest common factor. 64x squared minus 32x. Marissa, what did they both divide by?
32.
32, a little bit more. X, you got it. Harmony, if I factor that out, what's it leave me with? 2x minus 1. Good. Now, when it comes to simplifying rational expressions, things in parentheses, binomials, will have to match other binomials completely on the other side of the fraction to cancel out. That 2x minus 1 is not going anywhere because there's not a 2x minus 1 on top. The only thing that's going to simplify here is the monomials. I've got 16x cubed y squared and a 32x. Ethan, what can I cancel out of both of those monomials?
16, 32, 1, 2.
Okay, anything else?
X squared.
Left with an x squared on top. X squared y squared on top over 2 and parentheses 2x minus 1. I could have had the 1 on top. I don't tend to write it. You can distribute the 2 back through now that it's simplified. I don't require that. I personally leave it like this. Still need my excluded values. Set my original denominator equal to 0, or in all technicality, you can always go with the factored version of the original. As long as you haven't canceled anything out of it yet, you can start with the factor. If you don't, it's not the end of the world. If I wrote 64x squared minus 32x equals 0, it just means the first thing I'm going to do is factor it. Which, between Marissa and Harmony earlier, we got 32x and 2x minus 1. And how do I solve that, though?
Put this up in parentheses equal to 0 and 32x equal to 0.
Yes. Far too often people leave the 32x off. You can't. It still has the possibility of being equal to 0. Solve for x, x equals 0. Solve for x, x equals 1/2. And yes, you're going to generally see me writing things as fractions. Are decimals okay? In my class, unless the instructions tell you otherwise, my general rule of thumb is if you can write it as a decimal without having to round, go for it. 0.5? Sure, you don't have to round. 0.25? Sure, you don't have to round. 1/7? Can you write that as a fraction or as a decimal without rounding? No. So, you will see me write fractions. But if you write decimals, that's fine, again, if you don't have to round. Okay, I've got one more just straight simplify problem, and then we're going to shift a little bit. And this one brings up, similar to this one brings up some common mistakes, this one also brings up some things that sometimes you'll see that mess with people, that can cause some issues. So let's talk about it. Four x squared minus 16, that's a y squared, over 12y minus 6x. First thing I want to do, yes, factor. When factoring, always start with your greatest common factor. Greatest common factor of the numerator, 4. Leaves me with x squared minus 4y squared. Greatest common factor of the denominator, 6. Leaves me with 2y minus x. Can we factor further?
Take 2 out of 1 6.
That's simplify. I'm not there yet. You're not wrong. You could do it now. It wouldn't hurt anything. Can we factor further, though? Can you factor x squared minus 4y squared?
+1 + 2 + 3.
You can't square root it, but I think you're recognizing that it's perfect squares. And if you have a difference, specifically of perfect squares, you have a version where you factor where you've got 1 plus and 1 minus. So, we can factor this further. Difference of squares tends to pop up a lot. Difference of squares goes into 2 binomials. First part of each binomial is the first thing that got squared. In this case was x. Followed by the second thing that got squared. What's the second thing that got squared?
4.
Not 4, because 4 squared is 16. What got squared to give me 4? 2. 2y, because there's a y on that as well. One's a plus, one's a minus. Can I factor 2y minus x? No. Exponents are 1 on both variables. You already did GCF. Okay. Quinn already pointed out earlier that the 4 and the 6 will simplify. They both divide by 2. That leaves me with a 2 up here and a 3 down here. Does anything else simplify?
Can't you cross off the 2 minus?
So,
Actually, no, you can't.
that's the big question. The 2y minus x and the x minus 2y look awfully darn similar. But, when in doubt, go back to numbers. 1 minus 2, 2 minus 1. Are they equal? No. But, one's a positive and one's a negative of the exact same digit, right? And that would always be true regardless of what numbers I used. 5 minus 3, 3 minus 5. One's a negative, one's a positive, same digit. In other words, they're off by a negative. Can I factor a negative out? When you factor a negative out, there are 2 places that it is appropriate for it to go. Way in the front of the fraction, that's traditional, or on the top, which is perfectly okay. Never leave a negative symbol in front of factor things on the bottom. So, I'm going to put it out front. I had the 2 and the 3. I have the x plus 2y. I factored a negative out of this one. That's where I'm going to go with. And if I pull a negative out of this one, I'm left with a negative x and a plus 2y. Are these the exact same thing now? Yes. Now these are the exact same thing. They're written a little different. They're written more like a negative 1 plus 2 and a 2 minus 1. But those are equivalent. So now those can cross off. So if you ever see ones that look pretty darn close, but they're off by which part's negative, positive 2, negative x, positive x, factor out a negative and you're generally going to find what you need. So, negative 2 x plus 2y all over 3. Again, you could distribute that 2 through the numerator if you wanted. You're not going to generally see me do that. Okay. That's simplify. The section's not called simplify. The section's called multiplying and dividing rational expressions. So, today, we're going to talk a little bit about multiplying. Now, I'm going to tell you right now, when I ask you to multiply, divide, add, or subtract rational expressions, I'm still going to just write simplify. The reason I'm writing it again is because now we're not going to do the excluded values. We didn't do the excluded values on the last one, did we? Honestly, excluded values on that one are a little bit weird, and we don't typically see excluded values like that. If I set this equal to 0, even its factored form equal to 0, two y minus x equals 0, there's not going to be much you can do with it other than solve for one of the variables. In other words, get a variable alone. But this excluded value is not a singular value. It's actually a line. If I were to solve for y, it would be the line y equals 1/2 x. Are you going to see a bunch of excluded values like that? Absolutely not. I talk about it as a, hey, this is technically a thing, but no, you're not going to see that probably ever again. Unless you continue on with math. You might see it when it comes to like a calculus class. But, sorry. Anyway, I wrote the instructions again because when we are multiplying, dividing, adding, subtracting, I'm not typically going to look for the excluded values. So, today we're going to focus in on multiplying rational expressions. Y'all learned how to multiply rational expressions in elementary school with rational expressions that look like this. In other words, just plain old fractions. 2/3 times 5/12. When you are multiplying fractions, what do? Okay, I heard like 3 different things. One of them was correct, 2 of them were not correct. One of them I heard or started seeing some people do is, a lot of people think, okay, you cross multiply. You multiply the 2 and the 12 and the 5 and the 3. No. You cross multiply in order to solve a proportion. If it was an equal sign between them, and you got a variable in there somewhere, that's cross multiplication, is when you're working with a proportion, with an equal signs between the fractions. No. The other thing I heard is you multiply the top, you keep the denominator the same. No. You do not need a common denominator in order to multiply fractions. That's an add subtract thing. To multiply fractions, you multiply straight across the top, you multiply straight across the bottom. 10/36. Do I leave it as 10/36? No. I simplify. 10 and 36 both divide by 2. 5/18. Does it simplify more? No. Some people prefer to simplify before you multiply, and you can. It's called cross simplification. If you notice something on the top simplifies with something on the bottom, you can do it before you multiply it. It gives you smaller numbers. You don't have to do this, but if you notice that 2 and that 12 both divide by 2, we could have done this. And then when we multiply straight across, why'd I write a 1? We end up with 5/18 right away. You do not need to do it that way. But I will tell you right now that knowing that you can do that helps with rationals. At least it helps you not have to write as much. Doesn't actually necessarily make anything easier, just easier on your hand. What is with all of the blues and purples and I want a bright color. Don't mind me. C over 5d times 15cd squared over 8a. It's just fractions, which means when you multiply it straight across. When you do this, I would, though, keep an eye on if there's addition or subtraction for a couple reasons. First off, if there is adding and subtracting and you're multiplying straight across, if you're truly multiplying, you're going to have to do some distribution. But if there's addition or subtraction, there's going to be something that we do before we multiply straight across. It's going to make our lives easier. If you want to cross simplify, you can. I honestly tend to do that more on the bigger problems, but hey, that's up to you. If you notice something simplifies here, go for it. Yes, there's plenty that does. Okay, but for now, I'm just going to multiply straight across. When multiplying, remember, numbers multiply, variables that are the same multiply together. They don't have to be like terms in order to multiply. 6 times 15. Y'all got calculators, right? It is 90. And I've got the c and the cd squared. When you're multiplying variables, what happens to the exponents? You add the exponents. So I got a c to the first and a c to the first, so it's c squared and d squared. When you are multiplying, you know it should go number and then alphabetical with the letters, technically. Am I going to get upset if they're not in alphabetical order? Absolutely not. Can it help simplifying sometimes for some people? Yes. Okay, 5 times 8, 40. D times A, D. And we simplify. 90 and 40 both divide by 10. If it ends in zeros, they divide by tens. There are far too many times that I have people look at it and just wait to find something bigger. Might there be something bigger? Yes, but you can divide it by 10 and then ask what divides out of both 9 and 4, which is a lot easier numbers than 90 and 40. Okay, anything going to happen to the C? No. D? Yeah, I got both on top and bottom. Left with one on top. A, nothing to cancel with. 9 c squared d over 4a. When it's monomials, it's pretty straightforward. When it's polynomials is where people tend to start to get a little bit into trouble. Not because of the fact that it becomes infinitely more difficult. No. It's because people do some steps that either make their lives harder or they do just some really bad math. The most common thing that I see when people do this is they automatically start crossing off these. Can we do that? No. Crossing off those is like taking 6/7, pulling the 2's out, and saying 6/7 is the same as 4/5. You cannot cross things off unless everything is in a form where all the things are being multiplied. In order to get things that have addition or subtraction in those polynomials into a form where they're being multiplied, what do you need to do? Factor. Now we can multiply these polynomials before we factor, or we can factor first. If you multiply them first, if you choose to multiply straight across, then please do lazy multiplication. Do not go through and say, okay, I have to multiply these, which means you need to remember fractions have groupings. So technically that's in parentheses, and that's in parentheses, and that's in parentheses, and that's in parentheses, and then you have to do this. And you're going to get a really large polynomial of degree 3. In other words, it's going to be cubic. And it might be in 4 terms. And you might be able to factor it by grouping. You won't. But you're going to get yourself into a situation where you have a form that you haven't been taught how to factor. If you're going to factor it anyway, when I say do lazy multiplication, I mean put things in the parentheses that they have, the invisible parentheses. And just shove them next to one another. Now they only need to go into parentheses if they are a polynomial. If they are a monomial, they don't need to. For those of you who think I'm talking gibberish right now, they only need parentheses if there's pluses or minuses. No pluses or minuses, legitimately multiply. Now from here to here, does that feel like a worthwhile step? For many of you, probably not. Hence the reason I factor first. In fact, I tend to factor and put them into the same fraction all at the same time. Can I factor x plus 4? No. I put it in parentheses when it's got a plus or a minus, and I move on if it doesn't factor. Can I factor x squared minus 8x plus 1? Yes. Greatest common factor? 1, not helpful. If it has a greatest common factor, monomials and greatest, aka like greatest common factors, singular terms without pluses or minuses always go in front. Full AC method or it's shortcut? Shortcut. 2 things that multiply to 12, but when I add them, I get negative 8. Negative 6, negative 2. So x minus 6, x minus 2. If I'm doing the full AC method, I pull it off to the side to do the factoring. Because the full AC method has multiple steps, and I don't want to write out everything here with all of those multiple steps. Okay, can I factor x minus 2? No. Put it in parentheses, move on. Can I factor x squared minus 16? Yes, it is a difference of squares again. That's a perfect square, that's a perfect square. It has to be subtraction. Sum of squares doesn't factor. First thing that got squared, x. Second thing that got squared, 4, not 16. 4 got squared to give me 16. And the symbols, 1's plus, 1's minus. Can I simplify? Yeah, what goes away? An x minus 2 and an x plus 4. I'm left with x minus 6 over x minus 4. I can leave them in parentheses, but since they are the only factors on each the top and the bottom, I don't need it. This looking familiar and doable? I got one more problem for you. Izzy, where would you like me to start? Factoring. How does 3x minus 6 factor? Take a 3 out, leaves me with x minus 2. Now again, I tend to do the factoring and putting it into one fraction altogether. So I'm going to move on to the other one's numerator. Isabel, how does this factor? Do they have something in common? A y. Leaves me with 4 minus x. Now, generally speaking, you don't actually want that y to stay in the middle. It is a monomial. It's going to go out front and get multiplied by the 3. For now, I'm leaving it there. On my next step, I'll put the 3 and the y together. If it was a number, like a 2, you actually multiply the 3 and the 2. Enter. What about my first denominator? How's it factor? Take out the y. Leaves you with x squared minus 16. Wait a second, does that one factor further? Yeah, which means we're going to have to. We don't have to do it right away, though. If you do it right away, that's perfectly fine with me, too. Okay. Kale, what about the last one?
6x.
Pull out a 6x. Leaves you with x minus 2. Now we do need to factor this x squared minus 16 further. In fact, if I get more complicated ones, whether it be that I recognize I'm going to have to do the AC method or that I might have to factor more often, sometimes I just pull them off to the side. I create a section where I say I'm going to factor over here, x squared y minus 16y, and I just do all my factoring off to the side. X plus 4, x minus 4. We did that one before. And then once I'm done factoring, I plug back into here. You don't have to do this. This is just honestly something that I found to be easier rather than doing it all together. Okay, but since I didn't do that, I'm just going to factor this now, which I already established was going to be x plus 4 and x minus 4. While I do that, I pull my monomials together. I've got a y and a 6x, my x plus 4, my x minus 4, my x minus 2, we start simplifying. Andrew, what's something you notice that simplifies? X minus 2s are dead. Vivian, is there something else that you notice simplifies? 3y and the 6xy would leave me with what on top and what on bottom? Yeah, I'll just do that. works better. Kate, does anything else simplify?
You could do the negative, take the negative out of 4 minus x.
I can take the negative out. Now, earlier when I did this, I went through, I wrote the negative, I wrote the actual factored out form. If you recognize that they are opposites, you also can just do cross, put the negative in front. You don't have to write out this with the negative factored out specifically. With all of that crossed off, Sarah, what am I left with?
-1 over 2x, x plus 1.
You can put the negative here, or you can put the negative in front. I personally prefer it in front.